What's up, dogs? I'm going to show you how to easily identify enantiomers, diastereomers, identical chiral, and meso. We'll work on some problems, and at the end of the video, there'll be more practice problems. The key is in the description. So for enantiomers, they have mirror images, and all of the stereocenter changes stereochem, meaning it goes from wedge to dash or dash to wedge, and there are no plane of symmetry within the molecule. For diastereomers, there are no mirror images. Some stereocenters change, but not all. For identical chiral, all of the stereocenters stay the same. They're the exact same molecule. And for meso, all of the stereocenters change, plus there is a plane of symmetry. Often with meso, you have two of the same substituents or two of the same groups. I also want to note when you flip a molecule upside down, the stereochem changes. On the left, you see that alcohol and bromine are on wedges, and when I flip it, it turns into dashes. Let's start. This is the first example. There is a mirror plane between these two molecules, and if I were to flip the one on the right, it would look like this. And as you can see, all of the stereochem changes. There are no planes of symmetry. Thus, this is enantiomers. Moving on to the second example. These compounds have the same groups. They have bromines. There is a plane of symmetry within the molecule, and stereochem changes. Thus, it is meso. Stereochem for SCH3 changed, but it did not change for alcohol, so these are diastereomers. Another way to know is on the left, this is trans, and on the right, this is cis. Let's flip the molecule upside down on the right. We can see that these are the exact same molecule, so this is identical chiral. Let's flip one of the molecules. I'll flip the right one. Remember, stereochem changes when I flip it upside down. We see that these are the exact same molecule, so this is identical chiral. Note that for these compounds, we have the same substituents, which are the methyls. And if I were to flip a molecule, these stay the same. And if I were to flip this right here, it would change from dash to wedge. And note there is a plane of symmetry. We could also do it for this side. Same thing. So these are meso. Let's flip one of the compounds. I'll flip the one on the right. We see that all stereochem changes and there are no plane of symmetries, so these are enantiomers. Let's flip one of the compounds. I'll flip the one on the right. We see that the stereochem for chlorine changed, but CN stayed the same, so these are diastereomers. Here are the extra practice problems. Again, key is in the description. Hope that helps. I'll see you next time.